We're talking about dependencies here today. We're talking about compose systems path, I guess, towards dependency redemption. This is a chance for us to share what we've learned, a chance for us to speak our development team's truth about what it's been like to use different tools, what it's been like to work on a multi-developer project for more than a year with open source and modular code all mixed together in one big functioning pile of solid software. The title's a little bit tongue-in-cheek, but at the end of the day, that tends to be our conclusion, is that the LabVIEW linking assumptions think that we are dumb, and it is constantly trying to help us from ourselves, from who knows what. So again, welcome. I'm Ethan Stern, and my co-presenter is Steve Ball. We are development team members. We're both CLAs, and we are both members of Composed Systems, which is a company, a small LabVIEW consulting development company in the US, and we have a member in Canada as well. We recently achieved NI's Center of Excellence certification. We value and use agile development, specifically Scrum, to track our product backlogs, to iterate on sprints, and to deliver working testable code to our customers. And as of late, as of the last year and a half, 2 years, we also really value open source, and we try to contribute actively to that domain. We value using those tools, using those processes. We've really come to value good source control, using the Git flow workflow through our Git client of choice, what we use Atlassian's Bitbucket as our Git hosting solution. Right now, we are not married to it. It's just what we use. It's what we started using, and it's been good enough, basically equivalent to GitHub and GitLab. We value dependency injection in solid software because you can't develop effectively as a team on a large project without doing those things, in our opinion. We really value those liberal licenses that let people consume each other's open source without having to pore over license agreements or wonder if you're going to get sued. If you kind of have that fear of using someone's open source, then it's probably not open enough to be broadly adopted. And all that other stuff. So we are using continuous integration for most of our project work, meaning when we commit code to our source control repository, it automatically gets pulled to our CI server. It gets recompiled, it gets built. There are build artifacts like VI analyzer test outputs, like executables, and like test reports. Okay, so where do we struggle? This all seems pretty easy until you try to do it, and even do it using the existing tools, unfortunately. We have this multi-level software stack where we have a vast number of G packages that are open source and available and free for anyone to consume. We have multi-developer teams where we have 3 or 4, 5 people working on a project at one time. And those higher numbers are more the outlier, but we routinely have 2 or 3 people working on one project at the same time, actively contributing changes to source control. We sometimes have customers contributing to the repositories and consuming the code that we produce. And even good customers struggle with the tools and the processes that exist when you pull the code and compile it and it just won't run. And of course, there's all of the compiling, which is frustrating as hell, and all the broken stuff when you think you've done everything right and it still won't load correctly on Steve's computer, even though on Ethan's computer, everything seems perfectly fine. All right, so there are 2 types of people in the world. Those who want to put everything in VI-lib, and those who have maybe been shown or taught a different way of doing things. Other programming environments, other languages, do not have a golden library on disk. You put all of your dependencies, and those dependencies get shared between projects. There are reasons that other things don't work that way. We don't like, having tried both things, we do not like putting everything into VI-lib anymore. I personally have tried things the VI lib route. I've tried G Package Manager for 2 or so years since Derek first introduced us to it at the CLA Summit in Austin. And we're going to show you that we have this sort of hybrid approach where we're still using some GPM and we're still using some of our internal tools that we've written. But I've tried it all these different ways. And these conclusions that we're going to present in this presentation are the result of a lot of trying and a lot of frustration and a lot of going back to the drawing board and talking to each other about what are we really trying to do here. I value easy customer use, not only because it makes our customers successful, but it makes us look good. Like, we're getting paid by the hour. And if I'm going to a customer site or telling a customer, yeah, you just need to pull this code, and then 3 hours later you might be able to run it, that's not good enough for me, and that's not good enough for my customers. I don't like doing the same grueling or excruciating basic work over and over again. You know, I guess just twisting the knife there at the end. If software engineering is your job, it's a choice to remain ignorant. Once you learn about things like Git, if you're not using Git, then you know, that's a choice. A choice you're free to make, but not if you work on my team. So the problem with VI lib, it's not source controlled. You put stuff there, that's where it lives. It's the golden folder. My experience with this, having maintained my framework, my open source framework as a VI package for a while, is that I spent a lot of time dealing with getting the package built, getting the stuff installed. It compiles for a long time. There's not a lot of update about what's going on. You know, this is not traceable. What was in there? This is not under source control. So I may have built an application for my customer a week ago or a year ago. What was in there when I did that? Right? You have to have additional layers of your process. It's not, I'm not saying it's undoable to know what was in there, but it's still a workflow and a convention and other work that is required to be able to backtrack and know how this existed at the time that you built that executable. And I also fundamentally disagree with the idea of putting everything there. Actor framework.lvlib lives in program files, right, under my LabVIEW version. That's not the same thing as whatever Biff told me was good to consume and turns out was total trash code. Those aren't the same thing, and I don't believe that they belong in the same folder or in the same hierarchy of folders even. And again, we see this through the lens of a systems integrator, of a developer for hire. I hate the word consultants, hence developers for hire, because we really try to have skin in the game. We see our customers as partners. We don't come in and tell them like what we think about stuff and then collect their money and walk away. You know, we try to be in it for the long haul with them and not show them anything or teach them anything that we wouldn't do ourselves. So how are we not trying to do this, right? Because, you know, we need to like look in the mirror here and say, are we just creating a new standard? Are we creating a new package manager? We think we're not. We are proposing that we are not doing that. But trying to be self-effacing or self-deprecating about this choice, because we realize it's a little bit of a crazy undertaking. So, you know, why reinvent the wheel? There's suffering in any one of these paths. One big flat repository for everything for our customer. Well, it's a, you know, it was a G package, or it was some kind of modular source code add-on that we brought into this project. Let's just check it all into one big repository. You're not going to get very far with that approach with a 3-developer team working full-time on a job before you realize it's absolutely untenable, unsustainable. One big package location, VI lib, I think I already said what I need to say about that. One virtual machine for every project. That's a nice idea, but virtual machines kind of suck. They're huge if you want to exchange them with colleagues. Anything that's cloud-based is slow and laggy in my experience. Even a VM running off of a solid-state hard drive sometimes is laggy when you try to open certain features of LabVIEW, and it's frustrating to me. It's personally frustrating to use. It kills my buzz with the IDE. Not that there's much of a buzz to be had anyway with the current gen IDE. But there's a lot to dislike about that process or that workflow as well. So in general, we succeed by avoiding poison, and we're not trying to reinvent the wheel. We're trying to leverage the tools that we have available. So we're talking about dependencies, right? What's the dependency? Well, I have a top-level application. That top-level application may call some proprietary modules, right? I'm giving you the most basic view of dependencies here. There are different layers. And what we're going to see is that there are different requirements and expectations for success at these different layers. All right, so this arrow, when you're representing dependencies in software, means depends on, okay? Yes, okay. So what is a LabVIEW package? It could be source code, or it could be pre-compiled code in the form of a packed project library, right? Whichever one of those routes you choose, we believe that a package needs to have some meta files, like a README and a changelog file, and a license in order to be open sourced. If it's for internal use, then you don't need to license that, of course, for your teammate to use it. And that it fundamentally has to have a semantic version. Okay. Without those things, your argument that your thing is a package is fairly illegitimate. And that last section, the bonus points, those bonus points are ways that we evaluate the quality of your package, right? It can be published somewhere publicly. It doesn't mean it's good quality. It doesn't mean it's robust. All right. Derek on G Package Manager was awesome, right? Like he has the tagline of write awesome LabVIEW, and it absolutely met its goal of teaching us, the Compose Systems team. We speak, on a personal level about this. It addressed this problem of project-based open source dependency management. My project for customer X uses these 17 packages, and I can pull them in and have specific versions that are known and tested on that project, checked in or associated with that project on disk. And if I flip over to a different customer's project, all I need to do is close my LabVIEW project and open the other one that I want to use. That is a fundamental shift, a paradigm shift from using workflows and dealing with long compile processes every time I want to switch projects. Now, it doesn't magically make compile problems go away, but that workflow is a little bit mind-blowing once you start to experience it. Okay. Gpackage.io will teach you everything you need to know about G Package Manager. It's still out there, it still works. And all of Compose Systems open source packages are available on gpackage.io. It gets the files, it puts them on your disk. It imports them into your top-level LabVIEW project, and it recompiles those files with the relative path changes. The problem we had was that this tool was not really designed for the depth and breadth of dependencies, dependency inverted dependencies, because they have to be, that we were using as a team. And we kept getting into predicaments where things were not compiling correctly. Okay, GPM solves this bottom level problem really well. It solves sharing these open source modules that don't have a lot of depth in terms of stacking of dependencies, hierarchies of dependencies. If you have a JSON parser or a lookup table or some other companies who's published to gpackage.io has, it's a great tool for getting that onto your disk quickly and consuming it. All right, since I'm not done ranting, things a package manager should never do. These are our team's conclusions, or my team's conclusions, our team's conclusions, after struggling with this and improving this process for a while. I don't ever want to get code that's not semantically versioned, unless it's from an internal check-in to a master branch, right? Those are the only two places I would ever really want to consume software. If we're not using semantic versioning schemes for an internal software that we're sharing between team members on a customer project, then perhaps we don't need to go through the rigmarole of semantic versioning. If I'm consuming anyone else's code from outside of my organization, it needs to be semantically versioned. Right? A package manager should never leave broken code on disk. unless, of course, that code is fundamentally broken. It can't program it correctly for me. It should never cross-link anything, ever. That problem is an immense pain in the butt. It should never accidentally deploy the wrong versions of code or lead me into that outcome. And it should never force us to adopt clumsy workflows and do unnecessary recompiles. If you're a real purist and you're one of those people who doesn't like Neil Diamond, sorry, Neil. Projects folder, unless it's a language feature or hardware driver. Okay. Actor framework can come from VI-lib. Great. Package management 101. I have an application, there's some project file in that folder, and then I fundamentally sort my code, my LabVIEW code, into 3 places. Packages, the things I'm consuming from an external place, the source code that I'm writing to make that top-level application real, and the tests that prove that that source code is not broken. Okay. The packages depend on packages. Inside that packages folder, I might be depending on these 3 composed systems packages. The MVA framework and the test executive both depend on the lookup table as a lower level component. Now that comes with this fundamental predicament. The MVA framework on the left there uses a package called the lookup table. And that is the relationship of those source code modules on disk. The top level application uses both of those things as well, but their paths change when I install them both as dependencies of the top level application. So abrupt segue into a quick plug for Git, right? We use Git. Steve told me that he saw the survey this morning on the GLA website, and something like 71% of people at the time he looked at the survey are using Git for their LabVIEW development. That's awesome. I think that's a huge change from 5 years ago, the types of poll results we were seeing at the CLA Summit. It's your friend, use it, it's awesome. It supports team development in a way that other tools and workflows don't, right? So over here on the right, we have an actual screenshot of a repository that Steve and Mache and I are working on for a customer. Of releases and pull requests that have been merged into the master branch. Right. So I show this as a disclaimer that the things that we are saying are going to be centered on this Git workflow. It's a Git-centric way of thinking about things. However, the workflows and tools that we are building and proposing do not require that you use Git. I think we've made it clear that we think you should, but there are many different ways to host your source code. There are many tools for discovering source code and installing it. And there are many places that legitimate, valid source code may exist on your hard drive. If you downloaded a vendor's installer and it put a driver in instrument.lib, right? The very first time we sort of rolled this out to anyone outside of Compose Systems and showed it to people, Chris Stryker said, well, what I really want is to be able to liberate a dependency from instrument.lib. Could your tool do that? And we were like, yeah, actually, it could do that. That's not the first thing we're building it to do, but that is something we're thinking about. We want to make sure that we don't close people out of using this workflow because they use GitHub instead of GitLab, or because they use zip files, shame on you, instead of source control. Because it's got to start somewhere. So remember that a package is just an idea. I mentioned earlier that you could have packed project libraries, or you can have LabVIEW source code. At the end of the day, that's code that I can call on my application. I can drop it on block diagrams, and I can use it. Again, our angle here is that a package is LabVIEW source code. And I suppose I can mention one of the main reasons why right now, which is that precompiled code prevents us from using one of the greatest recent syntax additions to LabVIEW, which is malleable VIs. Do we love everything about them? No. I don't love the namespace change when I have to change a VI from a .vi to a .vim. But this a la carte polymorphism where I can sprinkle this around and give myself a vast amount of reuse simply by marking something as malleable, it's really awesome. If you make PPLs, at least right now, and I suspect forever in current gen LabVIEW, because I don't see how it would be possible otherwise, but maybe there's some magic and I can do. You can't have malleability. A lot of our APIs, at least you cannot have malleability in a public part of your API. You can have malleability that you consume internally. But exposing that malleability through an API is an awesome improvement to APIs. And that is not something we're willing to leave behind now that we've experienced the simplicity that it introduces in code. Right? So if a package is just LabVIEW source code, and we're already putting the source code in Git and controlling it and merging to master when it's released, maybe even tagging it with a semantic version number, Git gives us two dependency management strategies. Submodule and Subtree are both Git commands that already exist. We just had to discover them. Mostly Steve. No. Right. So Git submodules, we've experimented with both of these, and we found that Git submodules really address the middle use case. I have a top-level application. It calls modules in the middle, which maybe calls some open source stuff. Right? Why would I want this? But what's special about mid-level modules? They might be proprietary customer code and not open source. They might be open source as well. That's perfectly fine. They might have malleable APIs, right, which we can't have with packed project libraries. This might be a large project that has a lot of modules in the middle, and I want to keep them, in effect, separated from each other, right? That's kind of the whole point of modularity, is to make our code easier to distribute, easier to consume, easier to understand. And I want separate Git repositories for these things. I don't want them all checked into one place. And of course, we're talking about a multi-developer team where we have different people consuming this. I might jump into Steve's code and make a quick fix, and he might do the same for mine. And we should be able to do that without stomping on each other's top-level stuff. So let's take a closer look at these submodules. There's nothing special about this. Right? I have a mid-level module with a nice and specific name. It's got a nice specific project name. That project claims, well, these three things: tests, source code, and externals. Okay, this is what Compose Systems calls this. We are thinking of these as external dependencies. They come from somewhere else. They are not the source code that belongs to this module. They are part of it. Well, lo and behold, we have the same path shift that occurs with Gpackage Manager, or anytime you try and take LabVIEW VI files, move them to a new place on disk, and compile them into this project to be consumed. This is a fundamental problem of an IDE that thinks it is smarter than you, right? So context is everything. I get this code on disk. I put my dependencies and externals. I recompile them so that they are correctly linked and claimed by this project. Source depends on those externals. Tests depend on those externals. Those externals are claimed in the project file. Maybe not every single piece of every single external is claimed inside that project file. So it might not, we have an example like in a project right now where there's some .NET stuff that we don't actually need to claim in the module level, because the module is unit testing the semantics of the API and the semantics of this actor hierarchy that starts and stops. We don't care about the concrete .NET interface. We care about everything else, right? So we can just circumvent this conflict of not having a driver the .NET in the project. It's a realistic use case, and it's really not that dirty. However, at the top level, we might want to claim that. Point being, this code is a snapshot of these externals, organized so LabVIEW understands them and can load them correctly for this module. Right, so submodule gives us a workflow for updating these dependencies. If you want to update a submodule, you would discard the local changes because they're compile-only changes, right? When I bring something on disk and I open it in the IDE, it does all this path finagling and relinks things. So I would discard that. I would pull the new code, I would recompile it, and open my project, and boom, I'm good. Right? So this gives us access to these packages directly from their Git repositories. If I want to update a submodule that I brought into a project, I can right now just do that, and this is how we do it most of the time right now with our current tooling, is I will go to my Git client, to SourceTree, the free Atlassian Git client that works nicely with Bitbucket. I can discard those changes. I do a Git pull, boom, I have the new code, I compile and I open it, and I'm good. And I think of a submodule like a pointer to the source files. Right. With a key distinction here, as we'll see with the next thing, that these dependency submodules, they are not part of the caller's Git commits, right? So these externals here, while they're consumed by this, they're not part of the source code. They're not treated that way. So subtrees. These are awesome for top-level applications. Why do we want a different behavior for top-level applications? Well, this is customer code. Well, why would the workflow be different? These aggregate lots of dependencies. Right? If you use dependency injection, you can have all of this modularity spreading far and wide. But when you go to run your top-level application, assuming you're not using a plugin architecture where you're dynamically loading things from disk, you need to dependency inject all of the concrete stuff in your top-level launcher, right? So this thing's aggregating on purpose the whole world that it needs to run. It's a very different way of thinking about dependencies than middle and lower levels of your software stack. And I ultimately want this top-level application to be quick to obtain, as in I can get the thing correctly linked on disk quickly and quick to build, because I might want to do a hotfix at the top level to change a numeric constant. And I don't want that to involve convoluted tooling or scripting processes to bring in new code. If I need to, open Steve's project, I want to be able to get that top level snapshot of my code in good working order as quickly as possible. So nothing here is different, right? We're talking about consuming dependencies. The dependencies are the same stuff. We're putting them in the same place. We're treating them a little bit differently. And here's the difference. When I'm using this top-level workflow that uses subtrees, I'm treating these externals. Git is treating these externals as part of the application source code. Right, so if one of my teammates has done their job, or I've done my job, I can pull down their code from the top level. Everything's going to come onto my hard drive, correctly linked, and I'm good to go. This also gives us the ability to modify and control the changes to those dependencies. So let's say that I had a module that was well written, but I needed to make a little tweak for it on disk so that my top level application worked correctly. Right? This isn't the kind of thing you would always do. If it's a real problem in the module, you should go back to that module, fix it, and re-release it and bring it back into your project. But there might be some scenarios where you want to actually check in changes to those modules at the top level, and this approach will let you do it. Right. So in summary, submodule versus subtree. And again, I said that we are thinking about this from a very Git-centric mindset. So I'm comparing these two things because in our opinion, as it stands right now, these two different workflows, pretty much solve all of our problems, and we're just trying to make the process of following these workflows better. So where does the source code live? Does it live in some Amazon bucket? No, it just lives in your Git repo. We're already paying for hosting there. It's already there. We already trust it. It's already controlled. Why would we also put it somewhere else, right? That was a little bit of a revelation to us. Like, well, why are we moving it elsewhere? Now, what is the package format? A package is a construct. It's an idea, right? You have LabVIEW source files, and you have other files that go with those files that tell you how to use them, that tell you what changed, and that tell you what version you're running. Supports private packages? Yeah, and this was one of the issues with, one of the limiting factors with G Package Manager for our workflows was that we wanted to treat those middle-level modules the same as we treated our open source packages. But there was no seamless way of saying, well, this is customer proprietary, and I want it to be hosted somewhere, and I want to consume it just the same way that I consume a G package, but I can't do that. So private packages, yeah, Compose Systems has loads of private repositories that only we can access because they're private repositories in our Bitbucket hosting. So if you can get to that repository, you personally, we want you to be able to follow this workflow to get that thing onto your disk and have it be installed and be working correctly. Of course it can implement these things. Can the source code in a Git submodule diverge from what's in your source code management system? No. If you recompile a submodule under a top-level application or under some other calling application, and you check that in, you're pushing broken, badly linked code back to that submodule. Please don't do that. However, as a subtree, those dependency files are treated as part of the main thing. And that is the fundamental difference here. So if the tooling's good, how would I get, maybe it's second level down from the top, how would I get all of my dependencies on disk and running so that I can work on Steve's code? I would pull Steve's code. I would maybe run a script or use a tool, like a one-button tool, to say, hey, get me all the stuff that this depends on. It would be brought onto disk from the cloud or wherever. It would be compiled. And then as soon as that was done, I could open it and use it. The other one being the subtree, where I want to just be able to pull it, not have to go through the rigmarole of compiling, and just use the code. Okay, so this is all about consumption, the subtree submodule distinction. A Git dependency does not declare itself to be a subtree or a submodule. The caller says, I want this thing, and I want to consume it this way because of other concerns that have nothing to do with the modularity of the code. All right. So submodules are great for everything in the middle and below. Subtrees totally rock for a top-level application. And again, this distinction is because of the way LabVIEW links its dependencies and its source code on disk and insists that those things be statically linked to each other as it loads them all into memory. So Compose Dependency Manager. Steve wrote a tool to help us navigate a lot of these problems. He wrote tools that script recompiling. He wrote tools that bring our externals from Git and put them on disk. What we are striving for is a tool that can handle a top-level application's consumption of dependencies, handle some mid-level proprietary modules consumption of dependencies, and handle open source modules consumption of other open source dependencies, all using the same tool, all using the same workflows. Right? We choose to believe this is all possible, right? We would have these things. We wouldn't have to duplicate our source storage. It's in Git already. You could pull from anything, right? You could, as Chris had asked, we could have a workflow in here because the plan is for this to be a very modular, extensible solution to pull a folder of LabVIEW source code from instrument.lib and treat it just like it came from Git. All right, so what idiots would sign up to write this? With that, I think it's time for me to pass the mic to It's Steve Ball, and he's going to talk about
Composed
Ethan, that was
the smoothest diss introduction I've ever had. Thank you. You called me an idiot. I call us collectively.
Sorry, that was the last minute chance. You didn't know I was going to call him an idiot.
Yeah, that was good. So we're calling this thing CDM. I spent way too much time making that logo, but we can move on to the next slide if you want. All right, so as Ethan said, we're creating some glue here to kind of script things, link things together to implement our Git-based workflows. What we experienced with our previous iteration that is called Composed CI, that implemented our workflow, but it didn't implement anybody else's because it had hard dependencies on VI Analyzer, VI Tester, which are things that we use internally at Compose systems. So we want to do better this time and correctly invert dependencies and make something that could potentially work for people outside of Compose systems. Again, in laying out the problem, Ethan kind of made the distinction between, these open source, publicly available dependency repos and what you would typically keep internal or private. We want to have kind of one workflow to rule them all. And while we're at it, this should work through the command line. And you should be able to access all the functionality because our plan is to run this on our CI server so that we can build and test our own projects, whether they be the open source or customer code. And it has to work every time because nobody wants to spend hours and hours of their life fixing the CI server. I guess I'm one to speak for that because that usually falls to me. And again, we believe in open source. So we're going to make this freely available to everybody, and hopefully it's interesting and potentially useful for a larger audience than just ourselves. Let's see. So the first thing we're targeting is a core feature set for dependency management. If you use Linux, you use RPM, Zipper, apt-get, any of those package managers, or if in the LabVIEW world, you have GPM, NIPM, VIPM, there's a million of these things. They're all just going to install, update, upgrade, or remove different packages. So here we're mainly dealing with source code rather than precompiled binaries, but this is how we're defining the problem that we're going to be solving. Okay, so to start to break down the problem a little bit, we'll start with install. What does that mean to us? So first, we have to get the code from somewhere, whether it's a folder on disk, somewhere in the cloud, or in our Git repo. It's got to be put in the correct folder, so exactly where we want it. Then typically, because of that path shift, we need to recompile it to make it happy. And then if it's a new dependency, we want to import it into our parent project for convenience. So we know, hey, what do we have? What's in here? And what we found is there's many ways to do this. You can change your LabVIEW search path. You can mass compile. And there's a lot of ways that don't always work the right way. So part of our CSCI package effort was to create a recompile that works every time, that's based on what's in your project. And so we've automated both the first two steps. So the git command to import the files into your hierarchy, and then the recompile afterwards. And then typically the import into the project we would do manually, but we have plans to automate that as well. If you screw this up, if you have, your search path is wrong and you open a different project, or if you have another project open and you open a different project, you can have cross-linking and compilation errors that can be pretty painful to recover from. From personal experience, this can range from downtime on the order of hours to days in a really bad case, and we shouldn't have to deal with that. So that's something we like to work around and script around. Move to the next one. All right, so steps. I'm defining an abstraction here. A step is concrete. It does work. It's LabVIEW source code. It has a CLI interface, so you can accept options, and steps can be run directly through the tool. There's no need to use another abstraction to contain them. And when they run, they get the context. What's the working directory? What's the project file? Everything they need to run. And right now, the step API has 3 methods. So it's the goal is for simple and straightforward implementation. There's a lot of existing LabVIEW scripting code out there that would be pretty easy to wrap into one of these steps. So that's also the goal is to make this quickly gain capabilities. So let's take a step back from a step and talk about what a command is. A command is an abstraction around the core functionality that I listed before. Like I'll have a command for install that is going to do those 3 steps in order every time. But that command exists. It's not source code. It's just a configuration object. But you can still pass it options. So as part of that configuration, you can say, oh, hey, if I pass, -C to my install command, it'll clear the compiled object cache. Or so you can add or remove or modify what steps are in the list for a command. And that gives it a little bit of flexibility, so you don't have, Ethan's install, Steve's install scripts floating around there. So it's a nice layer to have. All right, and so when we run the install command, it's going to do the 3 steps: get dependency, recompile, and import. And we've got some fly-in text that is going to appear. So when I run get dependency step, the context is going to give me where's the dependency I want to install and where do I want to put it. When I run the recompile step, Ethan, if you want to click through on these, it'll probably coordinate a little bit better with what I'm saying. It's all good. When I run the recompile step, it's going to give me the package folder and the settings for my recompile. Like sometimes I know that I only want to recompile the new dependency as I download it. Other times, if I already depend on that package, I'll want to recompile my project source code, but I won't want to force everything to recompile unless something's not working right. So there will be hooks and ways to do those kinds of things. And then on the import step, we've had mixed success. A lot of times, it might be a good idea to ship your unit tests or your examples with your package, but I don't want to import those into my parent project all the time. It's a nice sanity check to have them there on disk and use them if I need to, but it adds a lot of VIs potentially, and there's a lot of save and load conflicts that could happen. So we just when we run the import, we can say, just give me the source code, libraries, and classes, and don't import anything else. So having the context available to the steps is important and convenient. All right, the next thing that we've learned is packages are defined by an artifact file. So GPM did this, in our opinion, really well. Everything that consumes packages gets its own package definition, although not everything that has a package definition is a package. To effectively manage your open source dependencies, your public dependencies, you need to rely on semantic versioning or some sort of versioning system. What's available to the steps as they execute, you would find other things in the artifact file, like what version of LabVIEW, where's the project file or files, what are versions, and even more information, who's the package author, where do you submit bugs to, things like that, are all things that should be defined in there. All right, so I initially started working on implementing this with the hope to have something to show you guys today. It's not at that point yet, but we have the basic structure. We're focusing on the command line interface first. We've got some unit tests. It's properly using solid principles. So I feel good about where it's going. I think the first thing I'm going to do is focus on implementing our Compose Systems Git-based dependency workflow steps and getting that working and tested. Around that time, that'll be when I'll open source the package. We'll start using it internally. We'll put it on our CI server, add a user interface, and add step functionality going forward to make it more flexible and useful to the community.
Yeah, and that step functionality is a place where, you know, we can ship this thing with the steps that support our workflow. But as Steve said, it's following solid design principles. So when Chris Stryker says, hey, can you do this with whatever's in instrument lib? We can either add that as a shippable increment, you know, an option of a way that you can import your code, or you can do it and add it to the open source repository so that everyone can benefit from that new ability.
Yeah, absolutely. The lists of steps is not fixed, and it's intended to expand over time, and not under Compose Systems control either. You can write your own steps and use them for yourself. So I put a couple of these questions in the chat at the beginning of the session, but I guess what I'd be interested in is continuing this conversation in the breakout room after our time is up, talking about how everyone is managing and dealing with the same problems, and get some feedback as to, I don't know if we've described our problem well enough, or find out how universal the need for a tool like this would be. So.
Steve, do you have any closing remarks? I have one thing I'd like
to
go
for it.
Okay. I just want to re-acknowledge that we are not trying to reinvent the wheel. We found the limitations of existing tools, but that with this whole process of discovery and implementation, you know, we owe a lot to the people who've tried to solve this problem before us. You know, Jim and JKI, Derek, who have built package managers, and Chris Cellino, who's, you know, working on his own project of how to make packages discoverable, right? This is a broad landscape of discovery, hosting, and consumption. And, you know, we are trying to make something that dovetails with the existing tools, and that lets people follow the workflows that they want to follow, that consumes the code from the places they know and trust. And, you know, just in general, I wanted to just clearly express that we are grateful to Derek and Jim and other people who've done work in this domain.
Yeah,
because we would have been nowhere without, you know, starting from their tools that were already robust and functioning in their own ways.
Absolutely, Ethan. And to extend that statement, right, we're not creating a centralized list of where you can get packages. We're working on the back end of that problem, where we just want a way to get the packages and manage them locally. So.
Yeah, we are fighting the current gen LabVIEW IDE. That is the villain here. Sorry, not sorry. I heard we're not the only people with pain and frustration about consuming modular software dependencies in LabVIEW. Right. I don't know what happens when I press the stop sharing button, but I'm pretty sure the internet doesn't blow up.
Sounds good. Well, I think anybody who wants to continue the discussion can head over to the breakout room. And thank you, everybody, for attending.